I'd like to demonstrate one more example of how logarithmic differentiation works, and I'd like to do this with the following function. This will be y is equal to x raised to the sine of x power. Now, the way that this works is, anytime you have a variable raised to a variable power, it's difficult to tell whether that should be treated as a power rule or as an exponential rule. As such, we have to use logarithmic differentiation in this case. So we have to use logarithmic differentiation. Step 1, take a natural log of both sides. Step 2, expand the logarithm as much as possible. This is the logarithm of a power, so we can bring down the power to be a coefficient in front of the natural log. So this will be the sine of x times the natural log of x. Step 3, implicitly differentiate with respect to x. So the derivative with respect to x of the natural log of y is equal to the derivative with respect to x of the sine of x times the natural log of x. The derivative of the natural log function is 1 over whatever the input was. Then we multiply by the derivative of whatever the input was. In this case, that'll be the derivative of y with respect to x. On the right-hand side, we'll need to make use of the product rule. Product rule states this will be the first times the derivative of the second plus the second times the derivative of the first. That'll give us sine of x times 1 over x plus natural log of x times the cosine of x. Next, we'll multiply both sides by y to solve for dy over dx. This will be y times. Simplifying a little bit algebraically, we'll call this the sine of x over x plus the natural log of x times the cosine of x. And finally, substituting back will get us to our final answer. Dy over dx is equal to x raised to the sine of x power times the sine of x divided by x plus the natural log of x times the cosine of x. If you wanted to simplify it more algebraically after that, you're welcome to do so, but I am content to leave it as is.